Hi guys, I'm going to go through some topics from A-level DT, specifically the Edexcel exam board, though most of the content will apply to AQA as well. I'm in year 13 and for Edexcel there is only one paper, which is on the Wednesday 5th of June. And here are 5 topics across the entire specification that in my opinion are difficult or I think have a higher chance of appearing in the 2024 paper. So we're going to go through printing, marking out techniques and marking out tools, heating, which is like welding, brazing, soldering, these 4 design movements, and lastly Six Sigma. So starting off with printing, there are 4 printing processes which you need to know: offset lithology, or also called offset lithography, flexography, screen printing, and gravure. So starting off with offset lithography, this is the one that's most used in sort of mass production. It's the most cost effective for larger print runs. So it uses a blanket cylinder. So here's the diagram here. There's 3 big cylinders, one of which is the blanket cylinder. So the ink is from the ink rollers onto the plate cylinder, then goes onto the blanket cylinder, and lastly onto the substrate. So substrate is the thing you're printing on, which is on top of the impression cylinder. One disadvantage of having a blanket cylinder, is it can lead to registration issues because the ink is sort of following through 3 different places. It may not all line up perfectly. And then one advantage of this process is that it can print using multiple colors. If you have a row of like a row of machines, it can go sort of from here into a whole nother machine which has the same 3 cylinders. And that's how they do newspapers, print color newspapers. So often newspapers, magazines use offset lithography. With registration issues, this here is a registration mark, so this almost cross shape. So the cyan, the magenta, the yellow, and the black, K stands for black in CMYK, all those 4 different colors can make any color, and those 4 colors each has a separate machine to print it on, to print the color, and when it all lines up, it should make a perfect sort of cross hatch, and that means it's all perfectly lined up. You'll also see these color blocks or color circles at the bottom of newspapers, and this is basically to check, again, for alignment issues, and check that each color is sort of strongly printed, has enough ink in like the ink chamber, or in the ink rollers. So that's offset lithography, the more sort of cost effective and highest quality process, with 3 cylinders, water rollers, ink rollers. So if there's like a 4-mark question, explain the process or draw the diagram. This is sort of the diagram you would draw. And then we can move on to flexography, which is somewhat similar. It uses the flexible sort of printing plates. 2 advantages: it has a high speed of printing and suitable for different substrate sizes, and honestly, like truthfully, a wide range of substrates. Like you can print on fabrics, you can print on plastics, papers, etc. A disadvantage is not ideal for sort of very rigid surfaces. It's more for flexible surfaces, flexible substrates. It has a limited resolution, so it's lower quality compared to, if you look here, lower quality than offset lithography and gravure. The printing plates are quite expensive, but of course they can be used for millions of times repeatedly. And this process is mainly used in packaging and label printing industries. So here's the diagram for this one. For rollers, you have the ink. There's no sort of ink rollers. You have an ink reservoir. The ink is picked up, travels up the analog roller, and the doctor blade here is what is what controls, I guess, the amount of ink that's supplied. You have your plate cylinder, no blanket cylinder, and then the impression cylinder, just like this one, with sort of your flexible printing substrate can just be sort of sat up there. So this is the diagram you would draw for flexography, and it's sort of second in lead for cost effectiveness after offset lithography. So both of these are quite good processes. Then you have gravure. Gravure is used for really high quality production, for like image reproduction. If you're printing some high quality images, that's what it's used for. So less common. It's definitely the most expensive one, but also has a really high quality as well. So it uses these engraved cylinders. So it has 2 cylinders. You have the engraved cylinder here. So each cell here almost collects ink, or has ink inside, and that is what prints onto the substrate. It has thick ink deposits, so a lot of ink is used, therefore making it expensive. High cost, the use of solvent inks sometimes is bad for the environment, and it's not economic, it's not cost effective for small print runs. Because of the thick ink deposits, you can have a really opaque, strong color, so suitable for dark backgrounds, and it gives you high quality sharp prints. So you have your substrate in here, impression cylinder. So all 3 of these have an impression cylinder. Your cells here on the engraved cylinder, ink fountain, doctor blade, etc. So this is the diagram for gravure. And lastly, screen printing. It's different from all the other three. You may have done screen printing in school before. You have a screen, basically just like a wooden frame. It's quite a relatively cheap, easy to set up process, low setup cost. You have some sort of image showing in the screen. So the screen itself has like holes and stuff. Um, so when you put ink on top and you squeegee the ink through, only some ink goes through, and that is what creates the image on the substrate. So you have a screen, a squeegee ink, the image, and the photo emulsion. Um, Basically, yeah, pressing ink through a mesh screen onto the surface using a stencil. So this screen here is a stencil. It also allows for thick ink deposits, allowing sort of opaque prints, and it's used on often t-shirts. And this is how letters on a keyboard are printed using screen printing, and it can work on like paper and stuff, all different substrates. This is relatively low cost, um, but it's not suitable for mass printing because each one requires um, its own like basically your own setup. Um, yeah, and quality wise, pretty low quality compared to the other three. Okay, now to talk about marking out techniques and marking out tools. This comes under sort of topic three. There's a big variety of different like techniques and tools you need to know. Starting off with calipers, three types of calipers: odd leg calipers, internal calipers, and external calipers. So here on the left is example of a picture of an external caliper. Internal calipers. Internal is used to measure. You can see here measure the distance between the openings, some sort of internal space, and then external to measure the external distance. And then odd leg calipers are basically just used to measure like parallel lines and draw parallel lines as well on metals and polymers. Then let's move on to the definition of accuracy versus the resolution of something. So accuracy is how close a measurement is to the correct value, to the required value. Resolution is the smallest measurement possible. For example, on like a ruler, it could be 1 millimeter. It's the resolution of the measuring device. 4 different squares: your set square, a tri-square, engineer square, which is this one here, and then a mitre square. So tri-square is used for wood. You normally can't say, like in, for example, exam question, if it's about metals, you can't answer with tri-square, even though it does the same thing. A tri-square is only for woods, engineer square only for metals. And then mitre square is this one here, used for 45-degree angles. Okay, a micrometer is used to measure distances. It's accurate up to 0.001 millimeter. And then vernier calipers, which is this thing here, is accurate to 0.02 millimeters. A micrometer, I'll put a picture on screen actually. It's often used in science and like physics. And there's almost a dowel that you spin. It looks like sort of like a clamp actually. And yeah, it's super accurate compared to vernier calipers, which can be digital or like analog reading. So you probably have these in school. It looks like this. You measure using here, and then you have to look at the number here to see where it lines up, and that's the sort of next decimal place along. So a densitometer is used to measure the opacity of basically paper, also of printing inks, to measure the darkness, how strong that ink is. It's nothing to do with density, as you'd expect, or as you'd think. And then here, marking, cutting, and mortise gauges. So a marking gauge, it has one pin. A mortise gauge has two pins. That's the only difference. So here is a marking gauge, has one pin, used to draw parallel lines. A mortise gauge is used to draw a mortise, for mortise and tenon joint. Because it has the two parallel lines, you can basically draw out the mortise, and also the tenon using that. It's also adjustable, like the height and stuff. A center punch is this device here. You basically smash it with like a hammer, and it's used to make a hole in metal, just to make a mark. So then when you drill, you can line your drill bit up with that mark you've made on the sheet of metal. A China pencil or a dry wipe marker. This is what a China pencil looks like. Basically, as far as I know, just used to draw mark on polymers. Yeah, it just basically works the same way as like a dry erase marker would. You can just sort of rub it out and stuff. But yeah, that's what the China pencil looks like. A scriber is used to make or show a fold line on polymers. If you're going to fold something, you scribe it. And then a craft knife is used for scoring polymers. Craft knife you would have seen in school, one of the sort of safety knives. Okay, so densitometer, we talked about a go or no-go gauge. Quite a smart device. It comes in all sorts of shapes and sizes, but basically it's some way of showing either you accept the product because it has the correct tolerance, or it's too big or too small. So often if you imagine you have like a cube and you want to double check the dimension of the cube is correct, you can have some sort of like opening, for example, like a square opening. If the cube fits in the square, okay, then it's the correct size. If it's too big, it doesn't fit, then it's too big. If it's too small, then you can have a smaller opening, a smaller square. And again, if it doesn't fit, if it fits, that's how you know whether to accept the product or reject it, because it's not accurate. It's the incorrect tolerance. So that's a pretty small way of doing that. Dividers is this thing here, used to measure the distance between 2 points, and then it also works like almost like a compass, and used to draw circles. And then the final thing that comes up in this topic is jigs and fixtures. A jig is used to guide the tool or the workpiece, while a fixture is used to hold it in place, hold the workpiece in a fixed position. The advantage of using jigs or fixtures is it enables repeated accuracy. So if you can imagine, instead of having to mark out the same piece or line it up each time, if you just have a block clamped in place, you just hit it against the block, and then you know for sure that's in the correct location, the workpiece. Enables repeated accuracy, so there will be less wasted components, and components are quickly aligned, which speeds up production. Okay, now to talk about welding and the sort of 4 heat processes. So MIG welding, which is metal and gas welding, is suitable for thin sheets of metal. This is the diagram here. The electrical arc melts the wire electrode and the base material. So it joins 2 same material, base materials, and the filler rod as well is the same as the material. So it basically all has only one material. The filler rod, which is the electrode, comes through the welding torch, is fed through the welding torch. Molten metal from the wire mixes with the molten base material to create a weld pool, and then sort of shield gas is fed over the weld pool to prevent atmospheric contamination, protect like the welding material, and then when that sort of cools down, that is what creates the weld. One advantage of MIG welding is it produces very strong welds. So welding itself means both pieces, both base materials are fused together because it all uses the same material. So chemically speaking, it's all now one material. However, with soldering, so brazing or hard soldering, same thing, just different names. It uses a different filler material and base material, so it can join dissimilar metals. The base material is not melted, only the filler rod. And yeah, so the filler rod is a different material, unlike MIG welding. It's used often in one-off or batch production, not really sort of mass production. And then there's a section about sort of hang flux powder in the process, which makes the metal flow better and prevents it. So yeah, welding, both pieces become fused together. Then we can talk about soft soldering, which is used in like circuit boards and electronics, jewelry, joining copper pipes. It uses a filler rod, which flows in between the metal surfaces, quite similar to the other processes. And oxyacetylene welding, it uses a steel filler rod normally to create the weld. The flame is focused at one end of the joint, forming a small pool of molten steel. The welding rod is introduced to the flame as the pool is pushed down the joint. So here the filler rod does not come from the welding gun. It's like a separate sorry, it does. Yeah, so just like in MIG welding, the filler rod comes through the welding torch itself. And then here again, we have argon gas. So when you were to draw a diagram, for example, a formal question, this is the diagram you would draw. And then in terms of preparing before the welding processes, you often have to clean the metal to remove any grease, any dirt, any debris. And then wire wool is a good material to basically scrub the metal with. It's a good abrasive, so it removes any grease and dirt. Safety things, wearing a welding visor, which is like a helmet to protect your eyes. But unlike sort of just goggles, it covers your entire sort of face. And then welding gauntlets, again, unlike gloves, gauntlets is this thing here. It covers the entire basically arm, protects your hands and your arm, and like a forearm. Wearing a protective leather apron, and then welding curtains as well to protect people in the surrounding space. And that is the heat processes. Okay, design movements. So here are 4 of the I think 9 or 7 design movements that you sort of need to know for edXL A level. These 4 I think have a higher chance of coming up this year, because as this picture shows on screen, I'm going to put some of these have come up many years ago, so they could come up again in 2024. So Art Nouveau. The key designer you need to know is Charles René Mackintosh, and this was around the years 1890 to 1905. So characteristics and principles of this design movement: wavy curly lines inspired by nature, copying like the female form, handcrafted style. They took inspiration from Japanese, ancient Greek, Arabic patterns, and Celtic crosses, which is this thing here. And they often use modern materials, or modern for that time, so glass and iron. And then Macintosh, this designer here, designed the Glasgow School of Art. Um, and then Art Deco, we can talk about 1925 to 1939 approximately. The key designer there is Eileen Gray. So principles: popular modernism with exotic influences, eclectic yet elegant style that drew on tradition, simultaneously celebrated the mechanized modern world. At the end of World War One, this design movement sort of gained popularity, and their consumers were interested in mass production. And there's a quote here somewhere about designing things, that like were um, based around mass production, use of bold colors along with black and chrome, so sort of showing here a lot of like metallic colors, expensive materials, for example, polished stone. The key thing you should know is form over function. Prioritize the form of something, then the function of how it works. Geometric, symmetric shapes, shown in here. This is the Chrysler Building in America. Simplified sculptural forms of African, Egyptian, Aztec art and architecture. So these sun rays here sort of follow the mimic the sun, the pattern of the sun. Okay, now let's talk about Bauhaus, which is 1919 to 1933. The key designer being Marion Bont. So machine aesthetic approach to form follows function. So similar to Art Deco, again, form follows function. Less is more minimalistic ideas, influenced by World War One, the industrial methods and materials, rejecting the use of decorations, really simplistic designs, such as the natural forms of Art Nouveau, embracing mass production to create everyday products for everyday people. So if there was a 9-mark question on any of these design movements, having quotes like this, for example, good to show the principles of that design movement. The products were designed for the assembly line, use of modern materials, for example, tubular steel, lack of personality, basically embracing simplicity to create designs that everyone could buy and could use. So to aim to create a whole environment so everyone has the same products that all match. So instead of designing just one coffee pot, for example, they would design like the entire set of like cutlery and kitchenware and sort of everything in a house. And then lastly, postmodernism. This one is quite similar to Memphis, actually. So yeah, similar philosophies to Memphis. Challenge conventional taste. Function follows form this time. Yeah, so style is actually the same as form over function. Yeah, so the form is more important than the function. Against the functionality of modernism, playful, bold, bright, colorful style, a lot of like abstract colors, a range of non-traditional materials like plastic laminates, neon tubes, so printed glass. Often anthropometric or zoomorphic features, challenging the traditional norms by deconstructing conventions and reassembling them in unconventional ways. So this example here of a shoe is a pencil case actually, but you wouldn't sort of think of putting something that looks like a shoe and a pencil case together. And this is what sort of postmodernism does. And if we think about Memphis, we think about like the carton bookcase. So bright colors, interesting shapes. So yeah, here are 4 design movements. I'm pretty sure, hopefully, one of these 4 come up in the 2024 paper. And lastly, Six Sigma. This is one of the topics at the end of the paper, end of the syllabus in chapter 12. Quite a more difficult topic. So Six Sigma was originally, I think, sort of originates from Motorola. It aims to improve output quality by removing the cause of defects. So they say there should only be 3.4 defects per million opportunities. So each opportunity is like a chance of error. So not like basically per million steps where something can go wrong. So 3.4 defects per million opportunities. Advantages of Six Sigma: impacts and profitability, increases profitability because there's going to be less wasted products, less mistakes, more like higher efficiency basically, and then therefore a higher customer satisfaction. Disadvantages is manufacturing costs can increase because you're more like being more specific about tolerances and making things perfect, and it can be expensive for small companies to introduce, and it also stifles creativity because they're aiming for perfection. So less creativity because it's going to cause risk, and more creativity can lead to more problems. This acronym for the different steps of Six Sigma: DMAIC. So define the issue, measure the extent of the issue, analyze where the issue occurs, you improve on the issue, you fix the issue using rectification procedures. And one good example is poker yoke, which basically means there's only one way of doing something. So a good example is SIM cards. Although they're just like a rectangular shape, they have a little notch in the corner, so you know the SIM card can only fit in one way. So that stops someone from putting it the wrong way accidentally or trying to put it the wrong way. And then you're controlling these things you're fixing using quality assurance, making sure it's sort of long, it lasts long, and that's like the maintenance of the entire system. So those are 5 topics that I think are quite tricky and have a relatively high chance of coming up in this year's paper. Good luck for your exams and subscribe for more videos.